Concept of continuous functions. In this module, you will learn about the concept of continuous functions. Look at the graphs of squared function, modulus function, step function, and signum function. Observe that graphs of squared function and modulus function are single unbroken curves with no breaks, and they can be drawn without lifting the pen from the plane of the paper. Such functions are called continuous, whereas the graphs of step function and signum function have breaks, so you need to lift the pen while tracing them. So, step function and signum function are not continuous. Such functions are called discontinuous functions. For continuous functions, a small change in the input values produces only a very small consequent change in the value of the function. Therefore, a function continuous at a point has no jumps or break around that point. Whereas, for discontinuous functions, even a small variation in the input values produces sudden changes in the value of the function. Therefore, a discontinuous function at a point will have jumps or breaks around that point. Mathematically, a function f defined on closed interval ab is continuous at an interior point c if the function is defined at the point c and the limit of the function as x approaches to c from left and the limit of function as x approaches to c from right are equal to the value of the function at c. But if either the limit is not equal to the value of the function at c or it does not exist, then the function is discontinuous at c, and the point c is called a point of discontinuity of f. For a function to be continuous on a closed interval ab, it should be continuous at every point of the interval, including the endpoints a and b. The function will be continuous at a if the right-hand limit at a is equal to the value of the function at a. Similarly, the function will be continuous if the left-hand limit of the function at b is equal to the value of the function at b. Since the function is defined on the closed interval ab, left-hand limit at a and right-hand limit at b do not make any sense. In this module, you have learnt that a function is regarded as continuous if the graph of that function is a single unbroken curve with no holes or jumps. A function f is continuous at a point c if the value of the function at c is equal to the limit of the function at c. A real function f is said to be continuous if it is continuous at every point in the domain of f. If a function f is not continuous at a particular point c, then it is said to be discontinuous at that point, and that point is called a point of discontinuity of f.